Build your own printed circuit board with EAGLE, Part 3, turning the EAGLE schematic into a printed circuit board. CADsoft. Welcome to this training module on turning the EAGLE schematic into a printed circuit board. In Build Your Own PCB with EAGLE Part 2, we introduced the schematic entry using the EAGLE editor. Of course, you can design a PCB with or without a schematic, but this training module will focus on how to enter a printed circuit board from a schematic, and this has the advantage of performing design rule checking. Let's look at the user interface of the layout editor first. The layout editor window opens when you open an existing board file or create a new board. The board editor window appears very much like the schematic editor window, only some commands differ in their use. On top of the window is a title bar which contains the file name and path, and then the menu bar and the toolbar. Below the toolbar there is the parameter toolbar which contains different icons depending on the active command. EAGLE accepts in different ways mouse clicks, text as command line, or from script files. On the left of the workspace there is the command bar which contains most of the board editor's commands. To start laying out the printed circuit board, you should open the schematic in EAGLE's schematic editor and click on the Board button. You will be asked whether you want to create a new printed circuit board design from the schematic. Confirm this inquiry. This should open EAGLE's board editor window. Once you have created a board for a schematic, you should always have both files open when working with either the schematic or the board file so that forward and back annotation work. This is important since it allows EAGLE to keep the consistency between the two files. If you close either the schematic window or the board file and modify anything in the other window, EAGLE will be unable to track the changes you have made. The default board outline is the Euro card for professional and standard editions and a half Euro card in the light edition. Now use the Move command to drag the various components to the desired positions. Devices can be clicked on directly or addressed by name. All the signals you created in the schematic are currently called airwires, thin yellow lines that are drawn in the shortest possible way, crossing each other as needed. They stay connected to the component pins even when you move the component around. Try to rotate components while moving them by right-clicking to untangle as many of the air wires as possible. The air wires are not automatically updated when moving the components. To do this, you should use the rat's nest command. The rat's nest command recomputes and redraws the shortest dimensions for the air wires after you move things around. A standard printed circuit board consists of several layers of fiberglass pressed together, with places for chips and connections between them called traces. When placing traces, pads, vias, and even text descriptions, it is important to place it in the appropriate layer. The table shows some of the more important layers. When creating a new printed circuit board, EAGLE adds all components to the top side of the circuit board. Most of the drawing commands in the board editor have a layer selection pull-down menu that you can use for specifying the layer you want to draw on. Use the mirror command to move a component to the bottom side of the board from the top, or vice versa. When all the components are placed appropriately, we are ready to start routing the printed circuit board. This can either be done using the Autorouter, which can be selected from the Autoroute command on the toolbar or using manual routing. For manual routing, select the Route tool. Now click on an airwire and EAGLE will start routing the connection. Use the right mouse button to change the bend of the routed signal. A click with the middle mouse button while the track is being laid allows the user to change layers. If you need to change the routing layer during routing by inserting a via, press the middle mouse button. In addition to manual routing, EAGLE offers an Autorouter to free you of a lot of tedious work. Although no Autorouter in any CAD tool will lay out a board exactly as you would like, the EAGLE Autorouter will give us some hints on how things need to look and where trouble spots are. Click the Autoroute icon and a dialog box will pop up. In this dialog, you can set the design rules. The default parameters will produce a double-sided board. The Autorouter can be restricted to work in only one layer by selecting other layers as not applicable. This may, however, generate some errors since some components, surface mount devices, are not routable on the allowed layer. Here lists what the EAGLE Autorouter can do. The EAGLE Autorouter is a 100% router. This means that boards can be completely routed and will indeed be 100% routed. The Autorouter is based on the rip-up and retry algorithm. As soon as it cannot route a track, it removes pre-routed tracks, it rips them up, and tries again, retries. The Autorouter is controlled by a number of parameters, such as the minimum clearances, the via diameter, the hole diameter of the vias, and the minimum track width. All of these can be configured in the Autorouter menu. When running the Autorouter, the Auto command, the Setup menu appears first. All the necessary settings are made there. This is where you specify the layers that may be used for auto routing and which preferred directions apply. Click the appropriate combination box with the mouse and select the desired value. You may also use the Load and Save As buttons to load different parameter set from an Autorouter control file or to save the current settings for future projects. With more complicated boards, the Autorouter may not be able to complete every single connection. The remaining connections are left up to the user to finish manually. Also, you may want to change the routed tracks by yourself. To do this, select the Rip-Up command from the toolbar and click the track which you want to change. After that, the Route command is used to do the routing manually. When routing manually, you can switch back and forth between the Route and Rip-Up tools as needed. The design rule check is carried out at the end of a board design. All the parameters relevant to the board and its manufacturer are specified in the Design Rules box. Use the Design Rule Check command to open the Design Rules setting window. When you finish the Design Rules setting, start the error check by clicking Check. If the Design Rule Check finds error, an error window opens automatically. It lists all the errors found. The window can be opened at any time by means of the Errors command. Each error is marked with an error polygon. Its size tells you, for example, in the case of a clearance error, about how much the limit is exceeded. If an error in the list is selected, a line points to the corresponding location on the board. In some cases, you might wish to tolerate an error. Use the Approve button to do that. The error polygon of the approved error will then be deleted. As soon as you have corrected an error in the board, you can mark it as processed. The final step in completing your printed circuit board design is to generate Gerber files. These are files used by most printed circuit board manufacturers to fabricate your board. The first step to create your Gerber file is to start the CAM processor by clicking the CAM button on the top toolbar. You will see the CAM processor window pop up. First, you need to change the device to Gerber RS274X. Next, based on the table as shown, enter the file extension in the file box and make sure the corresponding layers are highlighted in the box to the right. Then select Process Job to generate the corresponding files. This completes the last step of the printed circuit board design. You now have all the files necessary to send to your board house.